So I'm building this really large Voron Trident, 400 millimeters wide and 600 and something tall. It's very tall, just because I could and it wasn't going to cost much extra. I realized there may be difficulties with vibrations and that sort of thing. Anyway, so I'm about to make its bed out of this huge bit of glass. Not really huge, but quite big, that I found at my local dump shop, complete with cat door. And I really mean the whole build plate, not just the surface to get a nice glassy texture. I think I will be putting PEI and a magnetic sheet on top of it. I just mean the actual build plate where normally you would use aluminium. Now, the conventional wisdom is that this isn't a very good idea for a few reasons, including flatness and potentially the loss of flatness or thermal expansion as it heats up. Also, the ability for it to break. But this piece of glass actually is very flat, at least at room temperature. I know this because I took it outside and looked at some reflections in it. Now, part of the reason why I think that thermal expansion actually won't be that big an issue is my MPCNC here, which I modified to be a 3D printer. It doesn't work all that well, but it does have a BL Touch, or at least a BL Touch clone probe, and I've been able to do bed meshes on it. So let's do a test. We're doing a bed mesh here at room temperature. Now, admittedly, this is not a great looking bed mesh. The motion system really isn't up to par on that machine. But for comparison, let's just remember that this one has a range of 0.5 millimeters. And now let's heat the bed to 100 degrees. Okay, that's up to temperature. And now we're doing another bed mesh calibration at 100 degrees. And, well, it still doesn't look amazing, but it's not that much worse than before. Range is still only just over 0.5 millimeters. This point here may be about 0.4 of a millimeter above this point. This is the 100 degree graph. And if we switch and have a look at the room temperature one, the difference between those 2 points is roughly 0.2 of a millimeter, which still isn't ideal. And 0.2 of a millimeter just isn't that bad, especially when considering my Voron Zero has a range at the moment of about 0.1 millimeters, largely due to its motion system. So I don't really think that the motion system on the Trident is necessarily going to be more accurate than the 0.2 millimeters that the glass bed is going to cost me. And remember, that's only if I heat it up to 100 degrees to print ABS, which I usually won't be doing. I'll mostly just be doing PLA at 50 or 60 degrees. So the curvature due to heat should be really minimal. Skipping forward a couple of months, the printer is largely put together. You'll see I have my nice sheet of glass that I cut to the right size. It was probably the nicest glass cut I've ever done. And now we're going to see how flat it really is by probing it with an 80XL probe on the tool head. I did buy a Big Tree Tech Eddy sensor that I'll use while this printer is actually in use to do leveling and probing and all of that. But of course, at the moment we've just got a sheet of glass that is not conductive, and I don't want to put a build plate on it yet, because what I'm trying to do is see if the glass really is flat enough before I spend money permanently attaching a magnetic base to it. So let's try it out. We've got it doing its Z tilt adjustment here, using just the 80XL accelerometer in the tool head. It's incredibly loud. And now the moment of truth, doing the bed mesh of the glass. And here's the answer. Not a great showing. This is pretty bad bed mesh, I would say. Range of almost 0.4 of a millimeter. So the next question is the glass bed causing this, or is it the motion system? And we're going to determine that by rotating the glass bed 90 degrees and see if we get similar or different results. The glass is rotated and we're doing the new bed mesh now. And look at this, it's about the same. So the curvature you're seeing here is actually not really due to the glass itself at all, but it's the motion system. I'm not sure exactly where the problem lies. I cut these aluminium beams myself and was very, very, very particular about getting them really accurate to maybe even sort of 0.1 of a millimeter. I spent a long time getting it just right. Definitely better than just 1 millimeter accuracy. Maybe they're a little bit bent. Maybe this Y beam is a little bit bent, and that's what's causing the sort of droopiness on the left of the bed mesh. The tool head itself is pretty sturdy, unlike my sort of adventures with my Voron Zero and its sort of head flopping around and stuff. This doesn't feel like that. It's pretty stiff. I have done this whole thing with the cable and the filament elastic to the frame so that it can get everywhere without tangling. I don't think that's really contributing. I don't quite know what else I could have done. I didn't want to use cable chains, and even if I did use cable chains, the Bowden tube would still have to be sort of routed in some way like this. I'm not exactly sure what other people do. I guess it's less of an issue if you're doing a smaller printer, but I insisted on doing this massive 400mm one. So I've now turned the piece of glass upside down as well to see what that looks like. And it's looking a little bit more... Wait, which was which? Yeah, the first side was a bit more concave, second side was a bit more convex. So the shape of the piece of glass is having some impact on this bed mesh, but not as much as the motion system. Now I need to decide which of these two I should make the top side. I'm thinking, because the heated pad is going to go underneath it, that means the bottom surface of the glass is going to expand more, making it more concave from the top. So if I go for the more convex option, hopefully that might kind of even out. We're going to find out. So now I've got the heater pad on the glass bed, and previously the glass bed was just sitting on its frame here, but I've now actually drilled holes through the glass and chamfered them so that these little countersunk screws can sit in them. I didn't film that process, but there's plenty of videos on YouTube. Even got a little thermal fuse there screwed in underneath the glass with some thermal paste. And got everything wired up to the bed now. I'll tie up some of those cables later. Now the manual suggested only tightening one of the bed screws really tight and leaving... I'm still not tightening that very much at all because I'm worried about the glass breaking. It suggests leaving the other two screws kind of loose, which I'm definitely going to do due to how easy it would be for glass to break due to thermal expansion. Doing yet another bed mesh at cold temperature, just so I've got something to compare it to. It's 17 degrees in here, it's a little bit chilly. And it's largely the same as before. Well, I was performing a PID calibration and the glass bed cracked. I think that's the end of my glass bed experiment. Gonna have to get an aluminium one. Whoops. So I think it would have worked if I had just set the maximum power level for the heater bed to less than 100% in Clipper in the config file. I'm setting it to 0.5, which is 50%, probably would have made it okay. I think this because I tried again switching on the heater, and it felt very hot to touch underneath the heater pad almost immediately, while the glass took longer to heat up, meaning there was sort of a big temperature difference, I guess, between the bottom and the top of the glass, in addition to just the center and the outside of the piece of glass, as we can see from where these cracks formed. Glass is a poor conductor of heat compared to something like aluminium, so that would have been what caused the bottom to get hotter much quicker and for the top to have not quite heated up in time. So I probably could have made it work, but I'm probably not going to try again with glass, and will order an aluminium build plate now.